Cool. All right, there we go. Yeah, welcome to lesson 5, last week of Software Saturdays. I was mentioning earlier, I'm sorry the week recording for last week has not been posted yet. I've been absolutely swamped with some other stuff, so I will get everything done probably by end of Monday at the latest. And I'll put that all in Slack once that gets posted, and I'll be obviously on YouTube as well, kind of follow us there as well. But today we're learning about APIs and React, which is kind of like our last big part about, React and web development in general. So quick reminders to be our 5th lesson out of 5. We have 2 project days, not the next 2 weeks for spring break. So we'll be off on, that's I believe, the 12th and the 19th. And then we'll be back for our 2 project days on March 26th and April 2nd. So we have, the project won't be due until April 9th. So you should have, we're starting now, about 4 or 5 weeks to work on. So plenty of time for you to get help, ask questions, work on your pace, and hopefully we can submit a certificate by the end of that deadline. That's something else. I'm sure everyone knows the slide pretty well, but obviously we'll still be hosting review hours, even though we aren't learning anything new. So if you want help with the project, please stop by for review hours. They'll be, again, they won't happen next 2 weeks. They won't happen for 2 weeks of the spring break, but we'll have all things posted in Slack. Just keep it on there for when and where those will be hosted. And then, of course, these slides are in Brightspace, so please follow along if you do there, and then join Slack for help and notifications. VS Code, demo files are on GitHub as well, and NPM. Okay, here we go. Review. All right, so week 3. What's up? He's not co-host. That is interesting. All right. Yes, give me 1 second. You're fine. All right, I will have to hop right back into a breakout room after this, so give me 1 second. Okay, I think we're back. Yeah, like I was saying, week 3 was custom JSX. So that was, again, the idea that we can just essentially wrap JavaScript or HTML in JavaScript and create customizable and reusable JavaScript HTML tags that we can embed in our projects. But they can be styled like any other normal HTML tag, and they can act like a normal HTML tag. In week 4, we covered about basic React. And basic React, again, mostly covering the idea that you can have props that are like parameters, right? You can pass them into your components, and they can change how React components work. Similarly, you can have states. State is more like a local variable. And therefore, the state allows you to kind of control how each component works individually. And then the classic example we use, I think, if I remember correctly, was the idea of like a timestamp, right? We could have a timestamp for each component, and the timestamp can be updated independently of each other. So they have like a local kind of copy of that kind of data. And then don't forget, of course, if you want to have like a callback for or a on-click handler for a button or other kind of interactive elements, you have to use the binding kind of phrase you put in the slides to bind this, since the keyword this is typically undefined in JavaScript in most cases. It has to be bound to a scope, as the name might suggest. And if any of this kind of sounds unfamiliar, please look at the slides and double check the recording as well. All right, this is going to be our last little bit about JavaScript and a little bit about React. All right, so components are obviously pretty cool, but there's a lot more we can do with them than just, it's displaying some basic data. One of the most fundamental things about it is the idea of a lifecycle hooks. So if you think about your normal web page, a component as you use it goes through several different stages in the process, right? It's first, created by the actual browser, and then rendered by the browser, and then shown to the user. And then when you leave that page, kind of removed from that browser as well, right? Well, it turns out because we're using a library like React, we can actually hook into these different steps in these different stages in the process, and actually run certain code at certain time about it. So these are called lifecycle hooks in React, and they only run at certain points in the actual lifecycle of a component. So there are a lot of lifecycle hooks for basically every part you can imagine of the lifecycle, but we only care about like 3 of them here. The first one is component did mount. as the name suggests, this is run only when the component is first loaded by the browser onto the web page. Component will unmount is the opposite, when the browser is about to unload the component from the page. And last one is component did update. So that's when the component does a re-render, right? Because you change some data, some state, some props, or what else you might have. And the browser is having to re-render the JSX. So you're going to have some custom code run at that element if you choose to. I would say that most code or most components tend to use the top two, right? Did mount and will unmount. A couple sometimes end up using the did update, but it's not super common in practice because it can be pretty challenging to use, properly. And if you notice the verbiage, right? Component did mount and will unmount, there actually are equivalents, right? There is a component will mount and a component did unmount. But these have been deprecated because they kind of suck. For example, component did unmount is typically never run by your browser because if the component no longer exists, it means that the page probably is closed, meaning you can actually run code, so why bother having that function hook? And component will mount doesn't really serve a purpose, right? Because why do you care if it did mount? We care when it finished mounting. Because before it mounts, stuff like props and state aren't defined yet. So we get a lot of code can be pretty small what we can actually accomplish in that lifecycle hook. So to keep things simple, pretty much the entire energy you can use is just these three, but mainly the top two. All right, and then a bit about JavaScript. There's one cool function that I think will come really handy for your project, actually, called the map function. This is basically a JavaScript function that takes it, you take an input of an array, and then it will return another array by running a function over every element in the array. So if you're familiar at all with Python, this is probably it's actually exactly like list comprehension, right? If you don't know what that is, it's a pretty cool part of Python. We can kind of create lists from other lists. And map is actually the exact same thing, where we can create lists by mapping each element of one list using a function to transform it to a different list. So you can see how this can be pretty useful, right? And I'm going to show you an example of why you would love this actually later on in this lecture here. So to use a list, it's actually super simple. You just give it the actual array name, dot map, and then use this kind of weird syntax inside here. And in more technical terms, it's called an arrow function. But all you have to know is that you give it in parentheses some iterator variable, element is what I call it here, but obviously whatever you want to name it, it's up to you. And then an arrow using an equal and a greater than symbol, and then some kind of simple command to run. For example, this one just doubles every element in every value in the array, some array, and will return an array called map output. So this is actually a very, very simple example. You maybe don't want to use this one, but in a more complicated example, you could actually, maybe say map a piece of data into JSX and then have an array of JSX to show to the user, right? That can be pretty useful, for you. And this is actually a super important part of API handling for this reason, because we can map any arbitrary data into actual JSX to the user in a very simple, easy one-liner. So with that, we'll jump into demo one really quick. Let me pop my demo one. All right, cool. So demo one is going to be in the GitHub repo. It's just going to be the demo one map and demo one HTML and JS file. So here's a very basic HTML template, kind of like I had a single thing too. The actual fun thing will be here in the actual map.js file. So if you take a look, right, at the function here, we have a function, or array, we'll call it, of numbers, 1, 2, 3, 4, 5. We then have two different mapping outputs. We then map each one to map output 1, where we just double it, like we had in the actual example. And then map, it's a bit more of a complicated function, right? An actual function, if you see that. We essentially do this kind of like a mod, right? So in case you weren't familiar, right? Any number mod 2 will tell you whether that number is even or odd. If the remainder is 1, then obviously the number is odd because that means that dividing by 2 is a remainder of 1. Or if the remainder is 0, that number is odd. Or sorry, its number is even, my bad. So what this function does is it goes to the elements, it mods it by 2 and checks if the remainder is 1. If its remainder is 1, it'll return the element, else it will return 0, meaning every even number should be replaced with 0. Finally, it'll just output, the numbers, the actual output of the map, and then some kind of arbitrary, 10305. So if you run this code, I'm going to run it in my browser here. In the run. And actually look at our web browser, our console, or browser console. You can see that the output is exactly what we think it is, right? The array numbers is 1, 2, 3, 4, 5. The doubling looks like 2, 4, 6, 8, 10. And the even odd kind of checker function we wrote does indeed return 10305. But one thing you don't have to, you might not, kind of is tricky here is you don't actually need to return the same kind of elements. I could, in this function, I could have returned a string instead of a number here, right? And that would have been okay. Because as long as it doesn't not matter what you return from your array, as long as you can deterministically map every element to a different element using the same function. So I could have said, instead of doing this, I could just say, this is going to be string element, this is going to be false. And if I actually rerun my code, I'm going to close it out, and then open up my browser again, you can see that the array looks just like normal, right? Because again, JavaScript types are very fluid. We don't care what we return as long as it is, using some value of the input to figure that out, basically. Were there any questions about the mapping function and how it can be used in JavaScript? Yeah.
Can you show me how you navigate them?
Of course, yeah. So I have a command line on Linux, so I just run the word Firefox space. I can't say it really well, but it does say Firefox space in the file name. But the way you'll probably end up doing it is you'll open it up in your let me figure out where it is. You'll open it up in your file explorer. For example, mine is located in this folder. And then double click it and it should open up in your web browser. Yeah. Yeah, now this is a fancy version on Linux, so it's a bit different, but honestly, the other way it works fine. And then also in the demo 1 is going to be our lifecycle function. So if we examine our app.js, we just have a demo 1 function right here, which is pretty cool. So we'll take a look at demo 1 in a bit more detail here. Demo 1. Okay, this is a pretty standard React component we talked about, last couple of weeks. Let me shrink them a little bit. So we have some props, which are just standard. We don't have anything to define here. We then set step to state 1, right? Kind of having some arbitrary state counter for us to kind of figure out what step we are in the process. Excuse me. We then say, we set state equal to 1 because the first step is constructing the element. We'll then see component did mount will print out that the component has mounted and that we're on step number whatever. Component did update will print out whatever, and component will mount will print out something else as well. And then render will just show what step we're on after the render process. The one key thing to note here, please, is the commented out line on line 19. If you can think about this for a little second here, right? If we were to set states after component did update, what do you think might happen? Remember, component did update is only called after the function has been re-rendered because some data has been changed in its actual render function. Any thoughts? Okay, let's do it this way, right? So we first mount it. We then call component did update because we have updated to initial state, right? We then set our states, right? But because we're also displaying the state right here, we have now changed our state, meaning we will re-render and then call component update again, which changes it again, which goes back to the same thing before. And suddenly the browser is an infinite loop where it updates the state, updates the render, calls a function, updates the state, and continues forever. If you actually uncomment this line, your browser will come to like a freezing halt pretty much, require a lot of huge memory and processor usage, and be kind of unresponsive until you close the web browser. So for kind of keeping things sane, don't ever actually modify state or a render using component did update. And that's also why it's not super useful for most people, because you can't really do a whole lot inside that function. But if we run this function now, wait for it to build and open it up and open up our web browser or our console, and I'll dock it on the side here if I can. Oh, I'm gonna dock to the bottom, I think. Okay, you can see that we have mounted, we updated, then we rendered, right? And you can see how those steps kind of make sense, right? The component is first created and loads the web page, we are mounted, and then updates or renders for the first time, so we call component did update, and then we render, then we do that again. It is kind of tricky to show you component will unmount here because it's not a very trivial thing to show off. But trust me when I say, in fact, will run, and you'll see a line number 4 on the bottom says, this is, step number 4 when the component did and eventually unmount. So does everyone understand how to use these lifecycle hooks? Yes, maybe, sort of. Okay. Yeah, you'll have plenty of chance to practice using them in a little bit as well.
So that should the order always go from mount to update, unmount to render?
It'll go mount, update, render, unmount. Yeah. Which again kind of makes sense in the process of a component as well. If you think about how it should kind of flow, it's kind of intuitive as well. So it's pretty useful. Cool. Let's hop back into this. All right. Like I mentioned, yeah, you can also just use map to map data, arbitrary data, into a JSX element for display, which would be extremely useful for API data. I guess don't turn number 2 time. All right. Forget about that. Okay, so for demo number 2, I'll just comment out. Oh. I'll just comment out that, uncomment that, and show demo number 2. Okay, first things first. The demo 2 component takes a prop, and the prop here is a number, or an array of numbers, right? 1, 2, 3, 4, 5, like we normally have kind of shown for a very basic math example. So all demo 2 does is it takes the props, it stores the props in itself, and then in the render function, we literally just map each number to a li. If you don't remember what li stands for list item. It's used to make a bullet point unordered or a numbered ordered list. So all our code does is it maps a list of numbers into some JSX tags, and then displays the JSX tags in a UL or a unordered list. Meaning, if we actually show it off to the user here, I'm gonna close this up if I could. There we go. You'll see that we see that the array numbers that was passed in right here. But again, React doesn't care what we passed in. So actually, if I made this some arbitrary data, like if I just said hello 2, 3, 4, we'll put a float here maybe. We'll say true. All of that will still render just fine. Minus the bottom one because true's a bit wonky in JavaScript. But the other ones show just fine. So again, you can map whatever data you want into a JSX element, not just numbers or strings or whatever. And that's again the power of map. We can turn whatever input data into whatever output data. There we go.
So is it like any amount of list of numbers, or is it like
Yeah, it can be any list again. Length is up to you. Okay, it'll just expand it or shrink it to fit whatever memory needs you have, I guess. And it can be whatever data format you want. Okay, so with that, we're going to use the tools we talked about today. We're going to go checkpoint number 1. Checkpoint number 1 will be in the GitHub, there's a card component. I'll show it to you in a second. Use the card component and map an array of information. Again, what you want to map is completely up to you onto the card component. So if you look at checkpoint number 1's code really quick, here's the card component is in the source component folder. And you can see that this takes one prop, which is name. So what you have to do is figure out how to take some data in app.js and map it to, or probably make a new component called checkpoint number one. And you're mapping it to, instead of li, like I did, map it to a card component. If you're not 100% sure how familiar with this, again, look at how demo 2 works and kind of work your way backwards from there. But the way I envision it, at least, is again, like a new checkpoint called checkpoint number 2 that kind of acts like demo 2 does in our function. So we have some input array, and this map function maps our input array onto elements, right? Data elements. Where instead of doing li, we're mapping cards. And the one catch here is, well, the li passes stuff in via just a null, put in the middle of the tag. Card does not have that. We had to pass in a prop to card, the prop being the name prop. So figure out how you can pass in props via this JavaScript expansion. I'll give you a hint, it's really, really simple. So we'll give you, I don't know, about 20, 30 minutes for that. And we will come back once we are more done with that. Okay, I think we'll move on. I think everyone's feeling pretty good about this. Part 3 is probably my favorite part of this course, which is APIs. Okay, first things first, what is an API? You may have heard the word before, but if you haven't heard the definition, an API stands for an application programming interface. It is used to send data to or from our code to another server, another program, another something else out there, basically. And everything on the web, and I do mean everything nowadays, is an API somewhere. Google Maps, Brightspace, your iTap machine stuff, it's all an API somewhere. And APIs are, again, to send data between what are called essentially black boxes. The idea being, if you're a server and I'm my code, I don't care how you run because you're private code. All I know is if I give you some input data, you'll give me some output data in some formats, and then vice versa as well. And we don't care how each other works, as long as we know that our contract of input data this format, output this format is met. There we go. Web-based APIs have basically nowadays standardized to something called JSON. And from JSON is basically JavaScript object notation, aka just a normal object, right, from lesson number 2, to send data in key value pairs. And the API that we're going to use is called pokeapi.co. So actually, let's go through Poke API. It has a really easy to use interface. You basically kind of give it a sample of a API call you'd want to make, and it'll tell you what output you'll expect to see if you were to actually make the call in your own code. So you can see that this is a very simple example, just making an API call, right, to this URL, https://pokeapi.co/API/v2 Pokemon/ditto. And the return for this API call is going to be everything you'd ever want to know about the Pokemon Ditto. Its name, its abilities, its forms, the game this appeared in, the moves it can have, the weight, everything you could possibly ever care to know about this one. And they have this for every Pokemon, right? For example, Pokemon number 1 is, I believe, Bulbasaur. Yep, Bulbasaur. You can say my favorite, Piplup, and learn all about Piplup if you wanted to as well. And you can even do more about types. For example, types. For example, type number 3 is a physical type, or this I guess is, physical type. And you can name about abilities, if you want even abilities, stuff like abilities, is every ability here as well. And what we'll be using mostly in this course is the last one, which is just giving it the word Pokemon. If you just ask for this Pokemon, we'll remove all this for now, and we'll come back to what that means in a second. It'll basically tell you how many Pokemon there exist in the database and tell you where to find more info about each Pokemon. So by default, it will return you 20 Pokemon, and you can keep asking for more and more, different levels of it. And if you see the results array, you see it's array because the brackets are, here. It will tell you the name and the URL for every Pokemon with their ID, right? For example, Bulbasaur is 1, Ivysaur was 2, and Venusaur was 3, right? That's pretty cool. But if you want to filter your data out a bit more, you can just put this back. You can give it limits and offsets. A limit is how many Pokemon can I return in one API call. By default, the limit is 20, but I believe 100 is the maximum as well. Yeah.
Is it going to be the first one that's programmed?
Yes, exactly. Unless we give it an offset. So if we say and offset, this is start from Pokemon ID, whatever. Again, by default, it's 0 because 0 is the most sense here. But if we say offset to 100, this will give us the first 100 Pokemon starting from the Pokemon number 200. I've heard of very few of these, but I'm sure they're great Pokemon. But if I said this to maybe say 250 or something like that, and maybe set limit to like, I don't know, 75, I would get 75 Pokemon starting with Pokemon number 250. So you can see we have an array of 750 items. Apparently, they give you that much. And it starts with ID number 251 and ends on ID, the very bottom here. Wow, it's a lot of them. Okay. Apparently, the ID is 10102. Go figure. So this is how you can actually, this is the API we'll be using for both this lesson and the final project. So if you're ever unsure how to kind of format an API call, just look at how they do it here and copy this URL basically, right? So to make an API call, we'll really send a request to this URL. Actually, go back to the more simpler one. We'll go this one. If I actually just copy this URL, we'll open a new tab. Can't see my new tab, so we'll just move it there. You'll see it returns a gigantic dump of information. This is not meant to be human readable. This is 100% designed for a computer to parse it and put it into a form that code can understand, not humans. Is that a question? All right. So again, these are again JSON. Remember JavaScript, right? You have objects, you have keys, you got values, you got arrays. These are all things that we can naturally and very easily manipulate in JavaScript, not necessarily with our human eyes. Keep that in mind moving forward. The cool thing about APIs is that data from an API can be mapped onto React components using map, as one might suggest. And we can essentially create a user interface that will change depending upon data we receive from a different server. Essentially, we can create two separate parts of our application, the UI and the service, and they communicate via APIs. Even further, we can now say, like, for example, like Google, for example, has their APIs for, say, Google Maps, right? And any device, your phone, laptop, your computer, right, all communicate to Google Maps via API, meaning they don't have to change their code for every kind of, different platform. It's a write once and use it anywhere you can support API calls from. And that's really the power of an API, or web-based API.
So they're communicating through API?
Through an API, exactly. Like actually, if I open up my network browser tab on this Google Slides, I guarantee you would see an API call to and from Google servers probably every couple of seconds, as it just updates in the background, doing whatever Google does in the background.
And then that's different from HTTP.
So there's a good question. It's a very tricky thing to answer. Essentially, HTTPS is how the APIs communicate. They make HTTPS requests and responses. Like your web browser also does that, right? It makes HTTP requests and responses, except the data gets back from the response is meant to be human usable. Whereas the data inside of an HTTP API call is not necessarily supposed to be human understandable. Yeah, it's a kind of tricky part. Basically, you can think of it like HTTP sort of carries the API, and the API is kind of on top of that pretty much. So how can we actually use APIs in React? That's demo number 3 here. If I can pop it open. There we go. All right, demo number 3 is just defined as a quick demo. So we'll just comment out some stuff here and uncomment here. All right, this is going to be probably the most complicated code you've written all day today. So follow along and use this heavily as a reference. Excuse me. First things first, we'll go to our constructor here. We have a callback binder, right? From our lesson 4. We're binding this to get API data, and we're giving it a blank array Pokemon, which is a blank array, as state, as initial state value. So far, so good? All right, cool. We'll skip the first 2 functions and go down to render on line 35. Line 38, as you can see, this returns literally a UL, right? Where the li elements are supposed to be inside the state, the Pokemon state array. If it's empty, there will be nothing on the screen there, obviously. But once you kind of fill it in, we'll see stuff kind of appear as bullet points in our list. So far, so good again? All right, cool. Next, we'll go to line 30, which is component did mount. You will recall this from earlier today, a lifecycle hook, right? This function only runs, yeah.
I've noticed like for every like demo we have a JS.
Yes.
Can you change that name, or should that be?
Oh, that can be whatever you want. I just do it because I'm lazy and I want to type out something different every single time. That name is whatever makes the most sense for your program. Yeah, it's completely up to you. Yeah, I should have maybe changed that somewhere else. Yeah, so component did mount does one thing. It calls a different function, which is not super, interesting to look at, but super useful for one really interesting reason. If you look at this line 12, right, where we define get API data, you will see the word async before the function, right? It's async space get API data. Why is that? Well, simply put, API calls can take a long time, right? If you have a very bad connection in your internet speeds, right, it could take a hot second for that to download the data, parse it, all that kind of fun stuff. So to make life easier, most things in JavaScript happen asynchronously, meaning they happen at different times in parallel, so to speak. This is super useful for one reason only. Component did mount will start this kind of call, a separate thread, so to speak, and then move on with its own life. If we had done the API call, what's called synchronously in the same thread, a big problem could happen where we now have to wait for our API call to finish before React can move forward. Meaning we'll pause the entire user interface waiting for a network call. That sucks, right? Because if a network breaks in the middle there, we can just freeze our entire page pretty much, which is horrible user design. Yeah.
Waiting for it to finish doesn't create different.
Define breaking, sorry. Define breaking, sorry, I'm not sure what you mean by that.
I don't know, because like breaking just means like it's not breaking. Whereas the finishing is it's kind of completed.
Well, both I guess are the same. Like I said, both, if either one happens here, right? Like basically, if it takes a long time, no matter what, if it failed to finish or didn't finish or whatever happens, what could happen is it'll pause React as well. And that means that even React will stop running, meaning nothing in UI is going to work after that. So to kind of circumvent that, we basically make the API happen in a different fake thread. Well, not really threads, but we'll call it a fake thread here. And then React can go on as normal, kind of doing its own UI stuff in the background. So that's why we say is async or asynchronously done. Are we so far on board with that? Okay. Now, a lot of this is pretty interesting stuff. The first one is we just define some URL. It is just going to be getting 10 Pokemon, storing at Pokemon number 0, right? So the first 10 Pokemon pretty much. We then fetch that URL. So we store in a variable called response. The one thing to note here is the keyword await before fetch. Again, fetch can take a long time. And we say await to wait for fetch to finish before moving on with our program. And that's why we want to move it to a separate again, fake thread here, because if we did this in component did mount, we could pause our entire UI waiting for fetch to finish. Now, in practice, this will probably not happen too long, but this is good design to make sure that we always have it kind of working asynchronously. Does everyone understand those first 2 lines of get API data so far, right? The URL, and then fetching the URL from some server somewhere in the world. Okay, cool. Line 16 is kind of a weird quirk of JavaScript. Essentially, response is pretty unusable. we have to turn response into data we can actually use. So we just say response.json to turn whatever response we got from the server into a code usable response JSON JavaScript object, pretty much. All right. And again, I wait because it can take a long time, so we want to kind of do it in the same thread. Is everyone on board so far with that? Are there any questions with those first 3 lines of code? Because they are kind of very new, and we're not going to talk about why or what those are too much in this part of the lecture here, but they are kind of important to use properly. What's up?
The process is save your URL and then one wait for it to be finally communicated to the computer.
Yep.
And then you transfer that.
Exactly it. Yep, you got it perfectly. Does that make sense? Everyone else? Cool. And then the last 2 are pretty familiar. We just take response JSON, we take the results key, because we looked at an array from looking at the Poke API documentation, and then we map each part of the array onto an li. And we just say the name of the URL and map it fancy. And finally, we set state, we store this new array of response Pokemon into the state array Pokemon, which will cause it to re-render and seeing all our fancy Pokemon on the screen. This code makes some sense to everybody at least. All right. So if you look at the web browser now, you'll see that, like we said, if you refresh the page, it pretty much quickly, because we're on a very good network here for you, we'll go through finding all 10 Pokemon, we'll fetching the API call, turns it into JSON, and then we display it to the user in a very nice to see format. Here's the cool thing. Again, if I change this URL, maybe I get 20 Pokemon. So we're going to Pokemon number 7. Find something really weird here. You can see that we have changed only one tiny URL, right? One tiny part of our code. But the UI naturally scales to handle that. Because React's meant to do this. React is designed to fetch data from an API and make changes to the UI depending upon what it is received. So now we can now display whatever we want to the end user. Is everyone on board with this demo so far? Someone understand how to use this? We get how to use the API in React with fetch. Somewhat, maybe, not really. All right. Yeah.
So the set state does what again?
Yeah, of course. Let me hop back there. So again, if you recall set state from last week, state is like private variables, right? So set state says, you know what? Replace the old Pokemon local variable with this new copy of it, basically. Oh, it does really, basically. So far, makes sense?
Yeah.
Perfect. All right, that's kind of all we had. So we'll come back to this in a second. That's the end for lecture today, basically. So again, actually, before we do this, I want to quickly go over the final project. I will publish this document on Brightspace and Slack probably again on Monday to finish some more stuff on this stuff. But basically, our final project is going to be a Pokedex kind of app, right? It'll be due on Saturday the 9th, April 9th at midnight. But if you need an extension, please just ask me. I will happily give you one for as long as you need, because I want everyone to earn a certificate pretty much. And if you ever need some help, the dates for all the help sessions are listed on the document here. We can see we have about 5 or 6 scheduled, so you have plenty of chances to ask mentors or us for help. And to submit it, just read the instruction on the submit part right here. So your requirements are here's what you'll get, and I'll put a link here for the demo once I finish the demo, probably Monday. But you will have this is your requirements for the project. You will have to complete these 4 A, B, C, D in number 1, and choose 2 of the 3 in component number in a box number 2. All of these are going to utilize all the skills you learned this past 5 weeks. It's a pretty kind of comprehensive project. You'll have to have 2 components. They cannot be app-related index that you make on your own. There has to be at least 1 with states and 1 with props. These can be the same if you want to kind of be a bit fancier or not. I'm okay with that. And there has to be at least 1 API call. And then you can optionally choose 2 of these, either include CSS, make a user interactive element like a div or a button, and then finally load images of each Pokemon. So I think the cooler one is probably B and C, but the easier two are probably A and B. So you want a challenge, go B and C. If you want to kind of feel a bit, want maybe a little bit easier, maybe go with A and B, or do all three. I don't really care. If you have some free time, go for it. And if you feel like you want to go for a bit extra challenge, you are more than welcome to try for an intermediate certificate. So those requirements on the second page of this document, they're a little bit longer. So this might be a little bit, out of your comfort zone, not a problem. But if you're kind of up to the extra challenge, all the links you're ever going to need are going to be right here on the top, as well as all the requirements are down here below. Yes.
So for API, so it does have this down.
Yeah.
Communicating to something on the internet, right?
Yes. Exactly, you got it. Yep. And the API here is the Poke API.
Okay.
And I had a link to it as well on the first page, if you don't remember what it was. Okay, again, I'll post this document on Slack on Brightspace probably by Monday night at latest. All right, okay. Checkpoint number 2 is going to basically be checkpoint number 1 and change your mapping to be data from the API. So basically, similar to how we adapted demo number 2 to checkpoint number 1, we're adopting demo number 3 to checkpoint number 2. Does that kind of make sense? Sorry? Same file is fine. I'm okay with that. But basically, what I'm thinking is your card component we just made earlier, right? Instead of mapping some kind of random data like we just did earlier, map Pokemon data from an API. So you can imagine that in your checkpoint 1 file, you'll probably want a lot of similar code to demo number 3. A pretty good kind of starting point for you there.